Today what we're going to do is look at indirect variation. As one thing goes up, the other thing goes down. Okay, so again, from yesterday we looked at as one thing goes up, the other goes up. Today we're going to look at as one object goes up, the other concept or object goes down, or indirectly related. Can you think of something where as you do more of one thing, another thing goes down?
Cleaning, and then bacteria goes down.
Good. The more you clean, the more time you spend cleaning, the less bacteria, or the amount of bacteria goes down. So what Anthony said is a very good example. If we're looking at bacteria growth, the more time you spend cleaning, the less bacteria there should be. Thus it is indirectly related. Okay, indirectly related. Yesterday we talked about direct relationship. As you do more of one thing, the other object goes up. Okay, the simple example yesterday was as your velocity goes up, the distance traveled goes up. So if you increase your velocity, what happens to the amount of distance you go? You go even further every time. Now, thinking about indirect, let's use the word inverse to remember that. Okay, now it's not the same as inverse, like 3/2 and 2/3 are inverse, because those are fractions. We're looking at inverse as in 1 over another object. So our equation that we're going to use today is going to be y equals a over x, as opposed to yesterday, which was y equals ax. Now we are dividing by x, yes. And when we think of inverse, we think of flipping a fraction. So if you wanted the inverse of something, x was up top yesterday, now x is down below. Thus the inverse. Think about it that way. Again, this is indirectly related. If we look at our first example, we'll start with in a minute, but if we think logically for a second, Anthony's example was bacteria growth is inversely related to the time spent cleaning. So this y was really the bacteria growth, and it was indirectly related to how much cleaning you put in, the amount of time, t. So in this case, if you spend more time cleaning, as you spend more time cleaning, the amount of bacteria goes down. Again, it's the same idea as your chemistry laws that we were talking about the other day. One of our easy ones to think about is if you decrease the volume of a container, the pressure goes up a lot because there's much less space for those molecules to spread out. So the simple example is volume and pressure. Volume and pressure are also indirectly related. If you increase the volume, the pressure goes down because now the molecules can run everywhere. The pressure is not as much, they're not hitting each other as often. So those two things are indirectly related. Let's start with an example. The example we're going to look at today to start, we'll do an application in a minute, but this is just a straight example with x and y. It says, if x varies indirectly with w, again, if x varies indirectly with w, and x equals 4 when w equals 6, and x equals 4 when w equals 6. Find the value of x when w equals -2. Find the value of x when w equals -2. Think about yesterday how we treated this kind of a problem. We started with our general equation yesterday, which was y equals ax for direct. We then found the value of a. We then looked at our specific equation to get an overall answer. Now, today we're going to do the exact same thing, but now it says x varies indirectly with w. Based on that statement alone, what kind of an equation can I start with?
Y equals a over x.
Good, but instead of y and x, what do I have?
Oh, w equals a over x.
Okay, or in this case, I'm going to write it this way, not that it matters, but just because I'm reading it the right way. X varies indirectly. X varies indirectly with w. That's my denominator. Again, x varies indirectly, that's that part of the equation, with w. Whenever you hear varies indirectly, it's a divided by something. Again, this part means x. This means varies indirectly over here. This means with w. What do I call this kind of an equation again?
Inverse.
It's an inverse, definitely. General equation. Again, the first one I write down was my general equation. Because, again, this is the general representation of inverse variation. Once we plug in some numbers, we can then find the specific equation that is specific to this problem. Again, to this problem. Now, it says find the value of x when w equals -2. If I put a -2 in right here, can I figure out x right now?
No.
How come?
Because you don't know what it is.
I need to know a. Again, if I know a and I know w, then I can figure out x. But I don't know a. So just by taking this -2 and plugging it in over here, it doesn't do me any good. So I have to use my other piece of information. Well, it says that x is 4 when w is 6. If I plug those in, what can I then solve for? For a. Be careful, we have x and w. So if we plug in what's underlined in green here, 4 equals a over 6. 4 equals a. What do we do, Andy?
4 over 1 on that side or something?
Oh, you can put 4 over 1. Make it easier, though. Bring it up. Just multiply by 6. Just take this 6 and move it up here. So you'll get 6 times 4 equals a. So a is just... Okay, again, that's all I've done so far is got the value of a. I haven't actually solved the problems yet. But again, notice, in this case, you just take the 6, move it up over here. Whenever you have a fraction like this, you can do that. It's the same thing as multiplying both sides by 6. These 6's cancel, you end up with just moving the 6 up. If a is 24, what should my specific equation now look like? Kelly?
24 equals a over -2.
Close? A is 24, Kelly.
Oh, okay, so is it x equals 24 over -2?
Very good. In general, though, over w. Then we'll write the -2 in a second. But this is now my specific equation. How do I know that? We take a look back up at the original equation we had. Our general equation is right here. Now that you know a, take the a value, plug it in right there. Once you know the a value, that's where this equation comes from. This equation is specific to this problem, or particular to this problem. Okay? Again, it only works for this problem right here, this equation. Now, the question said, find the value of x when w equals -2. Well, now I can plug a -2 in right here, and I can find x. Okay? And here we're going to see we have 24 over -2 or -12.
Oh.
Again, in the beginning, we could not find x because we were only given w. We didn't know a. Once we determined a, which was 24, we were able to plug that a value in and then go ahead and divide by the -2. Now, let's go back for, I'll give you a second to write. Let's go back to the first slide real quick and take a look. This was my general equation for inverse variation. Can somebody tell me, if I want to find a, what can I always do? By what? Good, so move the x up over here, right, if I want to find a. So a is really always x times y. Again, remember from yesterday, a was y over x. That was direct relationship. A was always y over x. Now, for indirect, a is defined as x times y. A is defined as x times y. Again, because I just simply moved this x up, this becomes xy equals a. So whenever you want to find the a value, just do x times y. Well, let's go back and look at our problem now. When we found the a value, what did we do? We really did x times y. But we called them, instead of x and y, we called them x and w. We had x and w. But again, if you want to find a, take the w and just move it up in this case. So you have x times w here. That's how we found the a value, x times w. So in this case, whenever you want to find the a value for indirect, just multiply x and y. As opposed to yesterday, when you wanted to find the a value, we divided x and y. Okay, again, we divided yesterday. So here's my value for x. Let's look at an example where we can actually apply this. It's a kickboxing example. Okay? And this is actually exactly right of how it would work with kickboxing and forces. I'll dictate slowly. In kickboxing, it is found that the force, we'll call F, the force F, needed to break a board is like a wooden board. The force needed to break a board varies inversely with the length of the board, L. Again, in kickboxing, it is found that the force F needed to break a board varies inversely with the length of the board, L. If it takes 5 pounds of force to break a board, if it takes 5 pounds of force to break a board that is 2 feet long, how many pounds of force will it take to break a 6-foot board? A 6-foot board. Comment or answer? Yeah, maybe that's the wrong one, but you know what? Okay, that's well, you don't know if you're right. There are many decimals, right? I'm just messing. Okay. So, how many pounds of force will it take to break a 6-foot board? That's the goal here. Now, let's start by looking at the beginning of this sentence. Can somebody come up and underline the things that are important in this problem? Underline the important things in this problem. Not just every random information, but what are we actually going to use from this word problem to solve here? Come on. Come on up, give it a shot. You're on the line, come on up. What is the important information? That's what she's going to underline. Give her a chance and then we'll make some comments after.
Wouldn't it be like 5 pounds, 2 feet,
Good.
and F, right?
Good.
This should have
60.
Good.
and that should be it.
There is some other stuff we
no,
can maybe
it's-
underline. Okay, good.
Line. Inversely.
What's this?
L. L.
Oh,
Inversely.
I don't think so.
Andy's trying to help you.
Oh,
Because that helps us write the equation. We don't know it's inversely. We
You
can't do
better
it.
listen.
huh?
You better listen.
That's pretty much all you need, actually, in this entire problem.
So
Look at this quickly. F, I would underline varies also, whatever. F varies inversely with L. If F, and we can look at the units, if F is 5 pounds and the board is 2 feet long, how many pounds of force will it take to break a 6-foot board? Everything underlined is what you need. The other stuff you do not need. Again, F varies inversely with L. Tell me, what equation can I write when I hear F varies inversely with L?
That'd be A equals X times Y.
We're going to use A equals X times Y eventually, but in this case, this is what I would start with. The force varies inversely with the length, with L. Okay, with the length. If you want to use a capital L, so you don't know, I'm just putting a script L. That's the way it's traditionally written. But if you want to put a capital L there, that's fine. The length. So the force varies inversely with the length. Good. That's the first piece. Next, the problem says to find the force with a 6-foot board. Okay. So I take the 6 right here, the 6-foot part here, and put it in for L. Isn't that all I have to do?
No.
What else do I need, Leslie?
You have to find for A.
Very good.
Y force times the L F is yeah.
Oh. Leslie already said we need to move the L up. We can say that A equals FL in this problem. Again, take this L, move it up here to find the A value. William?
5 pounds.
We know that it's 5 pounds, good, and what's the length?
2 feet long.
Good. So A is 5 times 2, which is 10. Now that I know the A value, as Leslie said about a minute ago, we know that if A is 10, we have the L, we can now find the force needed. So here, again, this was my general equation. Now my specific equation will say just 10 over L. Again, that's the only change I'm making. The general equation has an A. The specific equation has the value of A in it. So we put the 10 in there.
Can you plug in the 5 and the 2 then? Oh yeah, it's 6.
Why don't I plug in the 5 and the 2 again, Andy?
Because you're looking for a 6-foot board.
Yeah, we're looking for a 6-foot board now. The problem says, what's the force for a 6-foot board? So we take the 6 from the 6-foot and put it in for L down here. And when we do that, we'll see the force equals 10/6. Okay, well, let's convert that. What do you get?
1.66.
Okay, 1.6666 repeating.
That's all.
That's it. And let's make sense of this now. We have to make sense of this problem. So draw yourself a quick graph down
I
here.
don't think it makes sense.
Put an F up here and put an L down here. When the force was, what was the first force? 5 newtons or 5 pounds? When the force was 5, it could break a 2-foot board. When the force was 5, it was able to break a 2-foot board. That's where this first point comes from, right here. Next, when the force was 1.6, it broke what length of a board? A 6-foot board. So for a 6-foot board, I need to go down here. We'll say this is going to be 4, 3, 2, 1. Okay, this is 1.6, halfway in between. So I'm going to go over here, all the way down to 6. Here's my other point now. Again, this point is f of 1.6. So this is going to be 6, 1.6. This is going to be 2, 5. Connect these two. You get an indirect relationship, which is exactly what the problem said. If you have a problem like this and you see that the slope goes up, it's clearly not indirect. That is direct. This problem said indirect. And think logically for a second. If you had a board of wood, and it was like 10 feet long, and it was, say it was fixed at both ends. So you've got a board of wood, and there's a clamp on this end holding it down, and there's a clamp on this end holding it down. And you were just to kick right through it. It wouldn't be that hard to kick through it. But if you had a board that was only like a foot long, same exact height and width and everything else the same, but it was only 1 foot long, and you fixed it here and you fixed it here. Try breaking a 1-foot board that's this big. That's very difficult to do. Whereas when it's this long, it's a lot easier to break it. Okay, the force is distributed differently on the different lengths. So here the idea is that for a board that is, only 2 feet long, it's very difficult to break. You need 5 pounds of force. But here, when the board is 6 feet long, it's a lot easier to break it. Thus, the force went down to 1.6. So when you get an answer, your answer is not always going to be correct just by looking at it. You need to actually make sense of the answer. Make sure that the answer actually has a reasonable explanation to it. Questions so far?
I have a question.
Yes.
But it's like it's not off topic, but it's like something like common. So can you like use this equation like our debt like the United States, like how much money we could put China into like without debt? Can you use this equation?
For debt?
Yeah, like
The equations that they're going to use for economics are a lot more complicated than just a simple inverse. I mean,
I know.
inverse is definitely in there somewhere, sure, but it's not as simple as just why it's inverse. But the idea of inverse relationship does come into play with that stuff. Okay? All right, let's look at the next example. Draw yourself a table. Draw an XY table on your paper, please.
How many lines?
Give yourself, we'll call this N and we'll call this K. Okay, we're drawing an XY table, we're calling it N and K. Give yourself at least 6 rows. Sorry, 6 rows. Okay, for this example, we are told that the function is given by the function k equals 12 over n. The equation is k equals 12 over n. So immediately, the a value is the 12. Again, remember, a is given in this problem. A is 12. Now, the problem is to find all the missing spots. Okay, to find all the missing spots here. So, on your own, just try and find the first 2 spots. Okay, there's no need to call out the answer. Try on your own to find the first 2 spots only. Using the equation on the far right, using this equation on the right, try and figure out the first 2 boxes that we have empty there. Try on your own. We'll go over in a second, guys.
That's me. That's me. That's it. All right.
We're going to go over in a second.
Oh, the notes will be on headline, right?
The notes are already on deadline. All right. Homework's on deadline already as well. All right. Okay. All right. So the video will be up there at some point tonight.
All right.
The first one's
Have a
4.
good day. Tomorrow after school, I'll see if you got the makeup.
Yeah.
Come on tomorrow, do?
Yeah, all right.
Okay. Okay. Now looking at this problem, you want to tell me the first one?
And the second one. You want the second one?
Sure.
I got 6.
I got 6 also.
How do you know?
Let's go through this real quick. In the first one, we are asked to find the value of k in this first box right here. If I want k, I do 12 divided by n. Well, n was 3. So that's where the 4 comes from for the first box. Now,
Would 12 be given?
12 is given. This is given you in this case. In this case. We'll talk about in the second one. It's not given what to do. Okay? Now, if you want to find n, if you want to find, I'm going to show you a shortcut. You can do them all. If you want to find the value of n, you know the value of k. K in this case is given as 2 right here. So put your 2 in. Now, whenever you have a fraction equaling a number, you can switch these 2 positions here. You can switch this position with this position. It always works. Okay, you should have learned this one in at least Algebra 1. Okay, if you didn't, it's all you're doing is you're multiplying by n, and then you're dividing by 2. Okay, you're multiplying by n and dividing by 2. But this is just a quick shortcut. So that is correct. 6 is correct.
So the next one's negative 2.
Now, if we want to, figure out the next few boxes, there's a quicker and easier way to do this. Take a look at the product of n and k in the first 2 rows. What is the product of n and k? Product.
Plus 1 plus 2.
Product. What does the word product mean? What is the product of n and k here? What is the product in the second line? So, whenever we see this, the product of n and k will be whatever a is. Because watch, move n up here. What do you get? You get nk equals 12. So whenever you have these problems that are inversely related, you can simply figure out what A is and then know all the rest. So here, Andy already said this is negative 2, because negative 2 times negative 6 gives us this 12. In the next one, we have 24. 24 times what number gives me 12?
0.5.
0.5. What is that as a fraction?
1/2.
1/2.
Oh.
You know that, Karen. Okay? So again, because 24 times 1/2 is 12. Try the next one. What do you got there?
216. Oh no.
0.6 repeating. What is that as a fraction?
One over 3.
No, not 56.
1 over 3.
Where'd you get to over?
1/6.
2/3. Very good, sir. 2/3.
So every time you wanted to write it, do you prefer for us to write it as a fraction or a
I
decimal?
don't like fractions.
I prefer fractions personally. I always do.
Why do all my teacher
Personally.
likes
Personally.
fractions?
If you write a decimal, it's not wrong. Now, remember, there are certain times where decimals work better than fractions.
What?
For the y-intercept,
Oh,
we
yeah.
want a decimal. For the slope, we want a fraction. Last one.
Negative 12.
Shut up.
What is the last one?
Negative 12.
Very good, Karen. The last one is negative 12. The last one here is negative 12. Now, let's look at a real difficult example this time. If we're given a table, let's say the table says C and D, and it's got numbers 3, 6. We got a 4, negative 2, negative 9, negative 2, negative 54 and a blank, blank and a 36, 2 and a blank. Now, in this kind of a problem here, you are not told whether it's direct or indirect. Okay? We need to figure it out. So, before we do that, before anybody makes any assumptions, let's go through some stuff. For direct, we were told that A equals Y over X.
It's indirect.
No, it's not right. Yes.
It's indirect.
For indirect, we are told that A equals Y times X. Well, in this case, we don't have X and Y, but we have C and D. It's the same thing. Think of this as X. Think of this as Y. Now, with this problem, the simplest way to check is the following. Make a column to the right of each of these. Think of this one as Y over X. Think of this one as X times Y. So this is your check on the left side here to see if it's direct. This is your check on the right side to see if it's indirect. Now, the way we can simply do it is by looking at the data points that we do have, which is only 2 of them. Again, we don't have a bunch of these. We only have 2 data points. One of them is here, one of them is here. If I do Y divided by X for the first one, what do I get?
What?
2. Again, take 6 divided by 3. You get a 2. What about negative 2 over negative 9?
0.2 repeat.
0.2 repeating. It's a decimal. 0.2 repeating. Okay, let's stop for a second. Now let's try the other side. What's 3 times 6 here?
18.
What's negative 9 times negative 2? So which one is it?
Indirect.
It's indirect. Again, because look, this does not prove anything. These 2 numbers are different. Thus, it is not direct. Since these numbers are the same, this will be an indirect relationship. So if I know they're all 18s, I can fill in the rest of these blanks. Easiest one, the bottom one, what is it going to be? It's a 9. Anthony saw that right away because 2 times 9 is 18. More difficult one. What is this one going to be?
Half.
What is it?
Half.
A half, because half of 36 is 18. Try 0.5 here, or 1/2. 1/2 times 36 still gives us 18. Again, we are searching for 18 every time. What about the negative 54?
1.5.
Negative 3. It's negative 3. It is negative 3.
I got that for you. It's
It's not negative 3. It's not 1.5.
is it
Negative 3 point something. 4 point. 4 point.
is Is it 0.333?
It is 0.33 with a negative, right?
Yeah.
So it's negative 1/3.
Oh, I thought we were up there. Oh, me too. I thought it was yeah.
Sorry, guys. I was on this one. My bad. We're on the next one next. So here, negative 1/3. How are we figuring this out if you don't know? Look, write an equation. Negative 54 times some value, whatever this is, equals 18. That's what you're doing. You're saying negative 54 times some blank, this is the blank right here, equals this 18. Just divide by negative 54 on both sides. You'll get negative 18 over negative 54, which reduces to negative 1/3. Finally, the last one, what is this?
4.5.
Again, how do we do this?
9 over 2.
4 times 4.5 is 18. Think of it as 9 over 2 also, because 18 over 4 is 9 over 2. So the last example here, we are trying to determine whether something is indirectly related or directly related. How do we do that again? The way to do that is to look at these values. If they match up, then it is that one. These did not match up, thus it was not directly related. These did match up. The 18 here and the 18 here. So it was indirectly related. Indirectly related. Now,
If it goes up and down, would it be direct and indirect?
what if it goes up and down, up and down?
You know how the graph for
Guys, she's asking a question. You're all being very disrespectful to her.
you know how the graph for indirect goes like down, and
Mhm.
then the graph for direct goes up.
Mhm.
What if the graph went up, down, and up and down?
Then it wouldn't be either of them. And yes, it is absolute value. We'll talk about that. But it wouldn't be either of them. If you had a graph that went like this, it's not going to be direct. It'll be direct sometimes and then indirect other times. And you can call that what's called a piecewise function. But it's neither of them. Okay? Okay, let's go over quickly. Let's take a look at an example. Let me stop the recording because we're done with this lesson.